So one sampling technique that scientists use is a quadrat, and we use this to estimate the abundance, how common a particular plant is in an ecosystem. And when we're doing this, what we do is we have to try and throw it in the field randomly. We don't want to just place it where there's a lot of plants. We do it randomly, and that makes the experiment more fair. So to do that, not really kind of looking exactly where I want to plop it, I'm just going to throw this at a decent distance. And then we're going to have a look and see what's in it. So this is where our quadrat landed. Now if we were measuring the abundance of grass, we would count how many squares we can see some grass in. So out of 25, in this case it's a nice safe bet that it's a full 25. However, if we're just looking at the buttercups are appearing in only 4 of the squares in the quadrat. So when we're measuring the abundance for the buttercups, we would say 4. If we were looking at daisies, we would only see them in 1 square. Now, within that square, it does look like that might be another one, but it's not. So there's definitely only 1 here. Now, we don't just throw 1 quadrat, we're going to throw several. So we'll have a look at another couple. Okay, so in the square, not quite as much, but that's what we get. We don't cheat, we don't throw it somewhere else, this is what we've got. So in this case, buttercups, we'd say that their abundance is 1. Grass is still 25. Not seeing any daisies in this one. So let's have another throw. Okay. So this one, got a wee bit more here. So buttercups, I would say that we have 1, 2, 3, 4. The other ones that you can see here, they're not full buttercups, it's just petals that have blown off. No daisies in this one. What we're going to look at now is pitfall traps, and really simple, just something like a yogurt pot, and we use these to work out the abundance of insects in an ecosystem. So all it is, a little pot, but you'll notice that there's 3 holes, some holes put in at the bottom. And the idea of that is that if it rains during the night, these pots would just fill up with water. So these are just drainage. We don't want the insects that we're trying to capture to drown, we're just wanting to be able to have a look at them, identify them and count them. Now, when we put a pitfall trap somewhere, we don't want to just put it slap bang in the middle of the field, because if we do that, it's going to be quite obvious to birds and things like that, and you're just going to set up an all-you-can-eat buffet for them. So we want it somewhere disguised and somewhere where we're more likely to find insects. So a habitat, a wee bit covered up, somewhere like under this tree is probably ideal. When we dig a hole for the pitfall trap, the idea is that the insect's supposed to fall into the trap. So we want to make sure that the trap isn't sticking out above the soil, because they're probably not going to climb over and into the trap, and we don't want it too far underneath. What we want to do is we want to try and get the top of the trap level with the ground as best we can. So now it's a case of just digging a hole. Okay, so once you've got the pot in, we then need to try and get it level with the ground, so that might just involve moving a little bit of soil about, just filling in the bits that you've been digging around, and build them up at the side. Cool, so that's our pitfall trap in the ground now. Now, one or two other things that we need to do before we're finished is, first of all, the insects are going to be in there. We're not going to leave them too long. You want to have a look at your pot after 24 hours, ideally. There's going to need to be a little bit of food potentially in there. So just a little bit of plant material, a little bit of soil. It feeds them overnight. And then the last thing we need to do is we need to camouflage the pitfall trap. And the easiest way to do that is just to put maybe a couple objects around the pitfall trap, and then just a few leaves. We don't want to block the pitfall trap, so we don't want it to seal it, we don't want a lid, but something sitting on top of it like that will just disguise the entrance. Perfect. Now we just need to remember where it is and come back and take a look at the results in 24 hours. So we've looked at how you would measure abiotic factors. So if we can think about sunlight and moisture, we can use one of these. This is a light and moisture meter, so sometimes they're combined. If we're wanting to look at the light levels for a particular set of plants, what we're doing is we need to use the sensor at the back. We have to point that towards the light source, which is going to be up there. Not a very sunny day, but never mind. And we have to have it low down at ground level because that's where the plants are. We point it towards the sun, and we don't want anything casting a shadow over the sensor that wouldn't normally be there. So if we're just having a look at the plants here, so on the sensor it's level G, which is pretty high. There's a lot of light, even though it's a cloudy day. It's still quite a lot of light available for the plants. So you can see the sensor there and quite high up. And when we cover the sensor up, it drops down. The second thing is the moisture meter. So the moisture meter, we need the probe and we have to set it to moisture. And you'll see it drop there when I did that as well. So it's no longer looking at the light. And what we have to do is we have to push the probe into the soil, and we want to make sure that each time we do it, we push it into the same depth. So you could put like a bit of masking tape or something on it just to keep you right. And when we do it, we push it in by this bit, not by this bit, because we're not trying to rip the whole thing out. And then push it into the soil, and we'll see what happens. So we can see the probe has been pushed into the ground there, and this time instead of it being a letter, it's a number, so 3.5. Now, given that it's been really sunny and there's not been a whole lot of rain, that's shown us that there is still some moisture in the ground. Now, if we try that again, but we push the probe into a different depth, we won't get the same result. So this is why it's so important. So if we take that out just now, before we use it again, we need to wipe the probe dry, otherwise the moisture from the first reading is going to affect the second one. So wipe the probe dry now. So let's see what happens when we push this into a different depth. We only just push it into the ground and no more. It's showing me that there's practically no water at all. That's because all the water on the surface is going to have evaporated in the hot weather. But when we push the probe just a little bit further in, watch what happens. So it's shot back up. Okay, so really important that we get the same depth every time and that we wipe the probe dry after each use. pH probes work in exactly the same way. This one it's not calibrated to detect pH, but you can buy some that have pH as well, and they would work in the same way as the moisture one, except instead of it being a moisture reading on the top, it's going to give you a pH number.